Okay, guys. Good evening, everyone. So we'll be talking about another AWS service today called Relational Database Service. As you guys know, the relational databases play the most important role in any application architecture. You must be using various relational databases in your own companies right now, ranging from Oracle, Microsoft SQL Server, MySQL. So Amazon has this concept of relational database service. It's a managed service, meaning you will be able to spin a new database server in cloud without you having to worry about a lot of underlying infrastructure stuff. You don't have to worry about patching your servers. You don't have to worry about operating system on the servers. You don't have to worry about taking the backups. You don't have to worry about taking a point in time snapshots. You don't have to worry about failing over from one database to another. So a lot of these activities that you typically struggle with, meaning the data architects or solution architects or enterprise architects that you struggle with, you can leave that to Amazon, and Amazon takes care of it. So you worry about, you have got your database instance, and you do whatever you need to do it for at the application architecture level. You create a new database schema, create your tables, you worry about your application architecture. Do you want to take the backup on a nightly basis? Leave that to Amazon. You just configure it, leave it to Amazon. Amazon takes care of it. At any point, do you want to take a point in time snapshot? Leave that to Amazon. Do you want to set up an active standby architecture? Meaning if active database is down, it will automatically be failed over to standby database. With a single click, Amazon takes care of it. You are familiar with this concept of availability zone. We have region and availability zone. Availability zone, for all practical purposes, it's a data center for us. So you do not want to install your database in a single availability zone. You want to set up in such a way that if one availability zone is down, or if hardware failure occurs on my database server, I want this to be automatically failed over to a database in a different availability zone, because availability for the databases is the most important one. So leave that to Amazon. There is a concept of multi-AZ. So that's the active standby architecture. So all of this, you will get the same reliability and performance of your databases, your traditional databases, but it's also very simple to use in the cloud environment, especially with AWS. So that's called relational database service. So let's take a look at it. So relational database service, it's called a managed service. The reason it's called managed service is because, by the way, it runs on EC2, your traditional EC2 instances. Your database will be running on EC2 instance. And you do not have to worry about the license cost for any of the supporting database engines. But it's called managed service because you will not be able to log into the underlying, you'll not be able to SSH into the underlying host machine, underlying virtual machine. And you don't have to worry about operating system patches or any of that. As a matter of fact, it's all managed by Amazon for you. Amazon RDS supports these 6 database engines. You have MySQL, PostgreSQL, MariaDB, Oracle, Microsoft SQL Server, and Amazon's own database called Amazon Aurora. Amazon Aurora is a relational database engine. This Amazon Aurora is actually MySQL or PostgreSQL compliant database. So what they did was, they've taken the existing MySQL database and then they removed all the fat and made it cloud friendly or AWS friendly to be specific. Similarly, they took PostgreSQL engine, removed all the fat, and then they made it much more performant, reliable, and made it cloud aware or AWS aware or AWS friendly. It's a high performant database engine by Amazon. So RDS itself is not serverless. We'll talk about what serverless is. Don't worry about it. There is a one specific database here, Amazon's Aurora. You can make it serverless. In fact, we didn't talk about what a serverless is and all, so don't worry about it. But essentially, all these databases, you'll be installing this database on an EC2 instance. So there is an underlying EC2 instance. There's no magic there. You'll be installing database on an EC2 instance, but you'll not be able to SSH into the underlying EC2. You'll be treating that as a service. It's a database service. So you'll have a host name, you'll have a port. You create your security group, open the port to whoever you want to, and start connecting to the database and start querying it. That's it. It's a managed database service. Make sense? And when you want to take backups, there is a concept of automated backups within RDS. So Amazon RDS creates and saves automated backups for your DB instance in Amazon S3. So let's say you want to keep it for 30 days. Anytime you want to keep a backup for 30 days. So what automated backups, what it does is, Amazon RDS, if you specify that, hey, I want a nightly backup to be taken of my database. So what it does is, within your own preferred window, it takes the complete backup of your database and put it onto S3. Anytime using that S3 snapshot, you will be able to create a new database with that. So you have it. So you can specify your own window. That's called backup window. You can say at about 2 a.m. Let's say you have your regular maintenance period, right? For every application. So within that maintenance period, you set up your scheduled backup, your automated backups. That's how it does it. And it takes the complete database backup nightly. If you specify that, you can go from all the way from 0 to 35 days, your retention period. So you can restore your DB instance to any specific time during the backup retention period, creating a new DB instance. What it means is, let's say you specified that you wanted to take the backup for 14 days. So within that 14-day period, every single night, it takes the complete backup, and then subsequently, let's say I set up my automated backup at 2 a.m. So it takes the complete snapshot and put it out there on S3. Every transaction that happens after I take the backup, what RDS does is, it will maintain the commits. It will maintain the transaction log. So let's say you want to take a snapshot at 7 o'clock. What it does is, it has a complete backup until 2 o'clock. So from 2 o'clock until 2 a.m. to 7 a.m., It has all the transaction logs. So it takes the snapshot as of 2 a.m. last night, and then it apply all the commits on top of it and give you database as of 7 a.m. That is the strategy it takes. It makes easier because it's taking a nightly backup every single day. So it will be able to give you, or you will be able to go back to any second within the retention period. Let's say your retention period is 7 days. Within 7 days, you will be able to resurrect your database or go to snapshot to any date and time all the way till the second. That's called automated backups. I'll show you how to do that. And there is something else called database snapshots. So database snapshots is a manual activity. It's a user-initiated backups. Let's say I want to take, it's a year-end, December 31st, 2020, and it's a year-end. I want to take a snapshot as of 12/31/2020, 11:59 p.m. I'm taking a database snapshot and putting it away. And since it's a user-initiated database snapshot, it is going to be there until you manually delete it. It's again stored in S3. You can create a brand new database instance using the snapshot also. It's the same concept, but the automated backup it's an automatic, as the name says, and it's a nightly backup. Database snapshot is a user-initiated snapshot. They don't get overwritten because you took it for a reason and you put it away. So let's say you want to take a production database snapshot as of certain date, and then you want to create a test database or QA database from your production snapshot. Absolutely, that's possible. So there are two kinds of backup types, automated backups and database snapshots. We talked about it. And there is another concept here called multi-AZ, multiple availability zones. So with the concept of multiple availability zone, what it means is you already know what an availability zone is. If you enable multi-AZ for your database engine or your database instance, what it does is it will create a primary database in one availability zone, and it creates a standby database in a different availability zone. And it will continuously replicate the data from primary to standby asynchronously. Sorry, actually it's a synchronous replication. So it's a synchronous replication happens from primary to standby database. The standby database is not available for you to connect or to read or write. Standby database is continuously gets the feed from primary database. Only you'll be able to connect to primary database. In case primary database is down for whatever the reason, let's say availability zone is down, or your underlying hardware failed, or whatever the reason, your primary database failed, it will automatically fail over to the standby database. So it's an active standby architecture. That's what they call it. Understand, as architects, understand this concept called active standby. There are two kinds of architectures out there in general. One is active standby architecture. The other one is active architecture, especially when it comes to the databases. When you say, it's not just, this concept is not specific to databases. In general, when you say active standby, that means only one instance is active. The other one is in standby mode. It's ready to take the traffic, but it's not actively serving the traffic. That's what you mean by active standby. But when you say, every time someone says active, when someone says active, what it means is both the instances are actively serving the traffic. So Amazon, Oracle database has a concept of golden gate. So golden gate is actually continuous replication strategy. With the golden gate replication strategy, you will be able to make both active and your standby, primary and standby instances, both of them are readable. So you will be able to write to either of them. So both of them are available. In fact, you can create an active environment with golden gate. Or some of the modern non-relational databases like Cassandra database. So with Cassandra database, Cassandra is one of the non-relational databases. So NoSQL databases, that's what they call it, right? So with Cassandra, you will be able to create an active, they call it ring, Cassandra ring. You can set up multiple databases. Both of them are available for you to read and write at the same time. But multi-AZ is not that. I want you to understand that this is an active standby architecture. Only active database is available. The standby database is out there in a warm state. That's what they call it. It's an architecture term. They call it warm state. So standby instance is in warm state. It's ready to take the traffic, but it's in continuous replication mode. You'll not be able to connect to the standby instance. Multi-AZ is for disaster recovery scenarios. When primary database is down, then you will fall back to standby. It will automatically be failed over by Amazon to standby database. You do not have to do anything. You don't have to change your IP addresses, or you don't have to change the DNS name. It's all automatic. If any of the data architects or DBAs are in this call, you guys know, typically when you want to fail over from primary to standby, you will have to update your IP address of the DNS names. You do not have to do it. Here it's all automatic. So multi-AZ is not for performance reasons. Going into the exam, please understand that multi-AZ strategy exists for disaster recovery reasons, not for performance reasons. You will not get performance, you will not use it for performance reasons, okay? So multi-AZ failover, the primary DB instance switches over automatically to the standby if any of the following conditions occur. Let's say if an availability zone is down, or the primary DB instance fails, or the DB instance's server type is changed. If you happen to change the EC2 instance server type of the primary, then it will be switched to standby database. Let's say there is an operating system issue on the DB instance, okay? Let's say the OS is undergoing some software patching, then it will be failed over to standby. Or you can manually fail over of the DB instance using with the reboot with failover. So you will be able to reboot your primary database with an option of failover. Then it will automatically fail over to the standby instance. So multi-AZ mechanism exists for disaster recovery reasons. It is not there for performance reasons. Make sense? Because both the databases are not available for you to read or write. Only one of them is available. Primary is available. When primary is down for whatever the reason, then standby becomes primary. Understand that. Probably the data architects or DBAs are familiar with this idea, but no, all other people understand that. That's about multi-AZ. And there is another concept here called read replicas. So read replicas are nothing but it's a replica of your database, but it's available only for read. So there are a lot of reasons why you want to do these read replicas, right? Let's say you have a database. It's a heavy transactional database. So you want to create a read replica of your transaction heavy database and creating a separate read replica, meaning it's a read-only database. So what happens is, it's a continuously data gets synced up from your primary database into this read replica in an asynchronous mode. So there will be a slight lag data between your primary database and your read replica. So have your application, the transactional application, point to your primary database, but all of your reporting needs are applications that would only need read information. Point them to your read replicas. So what are you gaining here? You're gaining the performance because you're splitting the traffic between read-write to read-only. All the read-write traffic will go into your main transactional database. All the read-only traffic will go into this read replica. Understand, there is a slight delay in the data because the data is asynchronously synced. In a multi-AZ environment, your primary to standby, it's a synchronous replication. This is an asynchronous replication. So there is a slight delay, but it's okay. Right? Because I'm gaining the performance. I can have 5 read replicas of my single database. It will continuously synchronously replicate it across these databases. And my main application where I'm going to write, I'll point to the primary database. All of them, everyone else will go to these read replicas. All other read-only applications, let's say my Cognos reports, my Actuate reports, or my other read-only systems, they all can safely point to my read replicas, so that I'm splitting the traffic strategically as an architect. Does it make sense? So let's take a look at it. Read replicas are used for performance improvements. Yes, multi-AZ, you use multi-AZ for disaster recovery reasons. And I highly recommend your production database instance must be multi-AZ enabled. It must be. There is no doubt about it, because being a cloud architect, you always have to architect for the failure. What if a one availability zone is down? Forget about one availability zone. That may be a big deal. What happens if your underlying physical server is down for whatever the reason? So multi-AZ is very important. Okay, read replicas are for performance reasons. So you will be able to split your read traffic to write traffic. You can create read replicas from primary database. Data gets synced up asynchronously from primary to read replicas. It's not asynchronous. In the case of multi-AZ, it's asynchronous. In the case of read replicas, your primary database is available for you to read and write, and your read replica is available for you to read. So both of them are available at the same time. That's not the case with multi-AZ. Multi-AZ, only active database is available. Keep that in mind. So you can use both the strategies, is what I'm saying. That's multi-AZ exists for a different reason, for disaster recovery reasons, if things go south. But this one is for performance reasons. So because it is synchronously replicating from primary to read replica, there could be a slight lag. And you can promote read replica as a full-blown database. Yes. Once you break your replication, and you can promote your read replica to be a full-blown database, then you can start reading and writing. So to create read replica, you must have automated backup must be turned on. Keep that in mind. Of course, you can have read replicas of read replicas. You can do that. It's a multi-layer. So any questions on that? So understand going into the exam and in general, the difference between multi-AZ and read replica. Okay. Now the next.
Yeah,
Go ahead. Manohar?
I have a couple of questions. Yes. So you said that it is active standby and active active, right? There are two different types, right?
Yep.
So is there any specific, like I understand what is active standby, you have one active and another one standby. What is its advantage over the active active? Is there any specific advantage that we should know other than, yes, we know the definition that it is active standby, what is active standby, but why?
So the advantage of active active, right?
Active standby.
Oh, active standby. Let me mute you. Okay. So it's the reverse. So the advantages of, understand the advantages of active active. In the case of active active, let's say, I'll tell you a real world use case. We used in my previous life, we used an API gateway software called AppG. They use Cassandra as a database. It's a non-relational database, and they use, we created a Cassandra ring between East and West regions, and it's an active active. So you'll be able to, so we were able to serve both the regions at the same time. But with active standby, okay, the architecture itself is that only one is available, the other one is ready to take the traffic. Do you have the underlying software to support that? If you have the underlying software to support active active, absolutely go for active active. If you, but understand, by going into the active active, you have a bidirectional replication. So both the databases, let's say A database and B database, A is replicating to B, B is simultaneously replicating to A, because your commits are happening on both the databases. Not everyone supports that. With the non-relational databases, they support that, but traditionally, if you want to go with, let's say, Oracle database, Oracle has something called data guard. So data guard is a one-directional replication. So it only supports active active. They have another tool called Golden Gate. You can use it for active active, but that costs millions of dollars. Does it make sense? Not everyone supports that. But active standby, in the case of active, that's a common theme, right? In the case of active standby, you are keeping the standby instance out there in case active is down. It's your failover scenario.
Okay, I missed one part. See, for what is it that you said is costs millions of dollars?
It's called Oracle Golden Gate.
Oh, the Golden Gate.
I believe it's, I don't know, it may not be a millions of dollars, but I believe it's years back, it's $1 million, I think.
Yeah.
Oh, Venkat, in the same lines, right? Active. So active standby is just the replica of primary, so it keeps getting replicated, right? So will it allow the writes? The active standby, will it allow the writes to it? Right?
Standby does not even let you connect to the database, actually.
Okay. Then the second one, active. What is active standby? You said it's bidirectional.
Active.
Yeah.
There are only two things: active standby. The other one is active. When I say active, there are two databases. Both of them are active. When you write to database A, it takes care of syncing it to database B. When you write to database B, it takes care of syncing it to A. So both of them are actively serving the traffic. You can send 50% of the traffic to A, send 50% of the traffic to B. Does that make sense?
So both will be allowing the writes.
Absolutely. Both will allow the writes. That's why it's not every database supports it. It's you're talking about, every time you talk about active architecture, you will have to be really careful to see.
Oh.
So Venkat, active is only for one available zone, or it won't support multi-AG, right?
Multi-AZ is pure active standby. I brought this active. The concept of active has got nothing to do with AWS.
No, availability zone.
In general, I wanted to bring up as, I wanted to make you guys as a cloud architects or in general architects, right? Just keep that in mind. That's all. It has got nothing to do with AWS. In the case of AWS, RDS specifically, we have this multi-AZ, which is an active standby architecture. Okay.
So active means both will sync up, both will serve each other, both will keep getting synced up.
Yep. Both will take the traffic. Both of them, you'll be able to connect to either of them, and it will automatically sync up both sides.
Oh,
It's more complicated because
yeah.
if you
Right.
if you have, that is why it makes a lot of sense with the non-relational databases, because you do not have, with the non-relational databases, you have this concept of eventual consistency. You don't have the ACID transactions, right? So that's why it's more predominant in non-relational databases.
Right. Okay. Thank you.
Yep. So it's a general architecture discussion, nothing to do with AWS active. Understand that. So another database here, one of the database engines that's kind of interesting is Amazon Aurora. We are familiar with Oracle, SQL Server, MySQL, Postgres, all of that, right? Amazon Aurora is really interesting in a way that what these guys did is they have taken this vanilla MySQL engine and vanilla PostgreSQL engine, and then they removed all the fat. They made it cloud aware, especially AWS aware and AWS friendly, and they kind of made it internet scale or cloud scale. Okay, so that is Amazon Aurora, and Amazon is really pushing everyone into Aurora area. Even when you try to create a new database, it's a default database that gets selected is Amazon Aurora. It's expensive. It's expensive meaning it's slightly expensive than these MySQL and Postgres SQL databases when it comes to RDS, but it's not at all expensive compared to your traditional data center database engines. So your licensing cost, you don't have to worry about it. So even if you're using Oracle within RDS, you don't have to bring your Oracle license. Everything is included. It's a per hour billing, pay as you use it, and that's all. Everything is included in that.
Okay. I got a question here.
Yeah.
Okay. See, when you said the expression Oracle within RDS, what does that mean?
Meaning relational database service. So
Oh,
relational database service is a managed service that supports 6 database engines. Using RDS, you will be able to create a Oracle database, MySQL database, Microsoft SQL Server database, Postgres, or Aurora. Does that make sense?
yeah. Okay.
Or MariaDB. So it supports 6 engines. You'll be able to create it. So you don't have to bring your license. Everything is included in the cost. So let's say you have a different scenario. Let's say your organization already owns Oracle license, and you got a good deal for 2 decades. You got some bargain price, right? So in that case, RDS doesn't make sense. What you want to do is you install Oracle database on an EC2 instance. So you create an EC2 instance and you SSH into EC2 instance and you install Oracle on it. That is not RDS. RDS comes under, it's almost like a platform as a service. Not almost, it's absolutely, it's a platform as a service. It doesn't come under infrastructure as a service. I want you to understand.
Okay, so that's why you said that you cannot SSH into that.
You cannot SSH into it.
Okay.
You'll not be able to.
It's a special environment. Okay.
You will not be able to SSH into the underlying virtual machine.
Oh, okay. So let me just understand this one. So the RDS where I'm doing, the RDS that you talked about, where we have hot standby, active standby, and all those things. See, those things are all this thing. My gosh, those things are all I mean, those things involve Oracle or something like that, or they are
Absolutely.
RDS? Oh, okay.
Absolutely.
So RDS works through all these things.
RDS is a service. So this service supports 6 database engines.
Okay.
You can use any of the database engines.
Okay, but see, RDS gives you hot standby, active standby, and all those other various combinations that you said. But Oracle's Data Guard, or you mentioned about Golden Gate, they also give those things.
Yeah.
So those things will operate in conjunction with RDS, or RDS gives its own things.
So if you want multi-AZ, you do not have to use Golden Gate or any of
I
that.
see.
It's a
Or
simple
Data Guard.
active standby.
Okay.
It's off the shelf. You just create your Oracle database and it comes default. You just select a simple checkbox saying, I want multi-AZ.
Okay, gotcha.
Then it automatically creates 2 databases, one in one availability zone, the standby in a different availability zone, and continuously synchronously replicates the data. Does that make sense?
No problem. Yeah. Yeah, it's clear.
So, yep. So this Amazon Aurora is a relational database by Amazon itself. So it's a MySQL and PostgreSQL compatible relational database built for the cloud that combines the performance and availability of traditional enterprise databases with the simplicity and cost effectiveness of open source databases. Amazon Aurora is designed to offer greater than 99.99% of availability. Underline that. Who will be able to provide you that 99.99% of availability? Right? And it replicating 6 copies of your data across 3 availability zones and backing up your data continuously to Amazon S3. It maintains 6 copies across 3 availability zones of your data. That's the beauty.
Okay, then another question I want to ask at this point, that is, does RDS, is there any difference between RDS Oracle and RDS MySQL? Because they're probably giving RDS where you are only loading the data into similar structured tables, and then you don't have anything specific to Oracle. Is it something like that?
No.
Or do you have all the system global area, then your $V tables, $V views, do you have them?
One second. So if you create a brand new Oracle instance using RDS, you are getting Oracle database for all practical purposes. That underlying database engine is Oracle, period.
Okay, that's right.
Okay. So if you are creating a brand new instance, brand new MySQL instance using RDS for all practical purposes, that is a MySQL database. Simple.
Okay. Fine. Thank you.
Okay. So this is Amazon Aurora, and Amazon Aurora comes with, by default, Amazon Aurora is a simple RDS managed service, but Amazon Aurora also gives you the second flavor. It's called Aurora Serverless. So this Aurora Serverless, if you can use this one if you want a simple, cost-effective option for infrequent or unpredictable workloads. If you have unpredictable workloads, okay, you don't know what kind of EC2 instance do you want to maintain. You don't know how much database size do you want to maintain. You don't know. You don't know a lot of things, because you don't know if you T2 micro is enough or C4 XX large is enough. You don't know. In that case, go for Amazon Aurora Serverless. It's a serverless. You don't have to worry about the underlying EC2 instance. You are not paying for that, so you'll be paying less, and then it will automatically scale up and down. That elasticity, it maintains it. So it will automatically maintains when you have less number of users. Suddenly, if you're bombarded with thousands of users, and it will scale automatically. So you can use Aurora Serverless.
So
yes.
if we go for Amazon, right, RDS, then it will be looking for, you should have your own EC2 instances and everything, right? You have to buy.
When you create, I'm going to show you, when you create database, it will ask you what kind of EC2 instance do you want to put this on. I'm going to show you that. I want you to understand it is a managed service. It does not let you SSH into the underlying virtual machine, but there is no magic is all I'm saying. Underlying, there is a real EC2 machine out there that it's automatically installing it, but it takes care of installing, it takes care of automated backups. So it takes care of operating system level patches, all of that. You are not worrying about any of that. For you, it's just a managed service. Make sense? That is why this comes under PaaS. Remember we talked about on day one, we have three kinds of cloud architectures. One is the infrastructure as a service, and the platform as a service, and the third one is software as a service. This comes under platform as a service. You're not worrying about the infrastructure there. He's giving you database as a service. But under the hood, there is an EC2 instance is what I'm saying. So you will be paying for the entire, if you create a brand new EC2 instance on, let's say C4 XXL large, you will be paying together. Of course, they're going to bill you together, but whether you use it or not, you are going to be billed 24/7, 365 days. Does that make sense? But Aurora serverless is not like that. Based on your usage, they will bill you. So go to services. If I take here, log into Amazon Management Console and click on RDS, or enter your RDS here. I do not have any databases, DB instances 0 of 40. And then I'm going to create a new database. Create a database. You want to create a standard create or easy create? I want to do a standard create. And then see, they're supporting Amazon Aurora.
What's the difference between standard create and easy create?
It's there are a lot of options will be default. That's all it is.
Okay.
So standard create, and I want to do a MySQL. And now you can select your, so edition is MySQL community database. So these are the 6 database engines it supports. If you want to create a simple Oracle database, okay, how simply you can create an Oracle database or MySQL or Microsoft SQL Server database. With a couple of clicks, you have a database in the cloud. And especially with your free tier account, there is a way that you will get it for the entire year. Your database is free for the entire year in the cloud. How beautiful is that? MySQL community, that's the edition. And the version, you can pick whatever the version. The default is 8.0.17, but you can pick 8.0.20 if you like. And the templates. Are you planning on creating a production database or dev test or a free tier? If you choose production, by default, multi-AZ is on. It's a high availability, fast and consistent performance. By default, it's multi-AZ is on. When multi-AZ is turned on, then you're paying for both the databases, active database and standby database. So for this class, I want to do a free tier. And what's your DB instance identifier? I'm going to call this as a weather database. I'm going to give you a simple use case here. So this is my use case, guys. We started in a previous class. So my use case is I will have a relational database. So my company is providing APIs for weather information. You give me the zip code, I'll give you the temperature. That's what this company's goal is. The weather information, the temperature lookup essentially by zip code. So you have the zip code and the corresponding temperature that's maintained in a relational database. Well, you can argue why it should be relational database and all, but I just wanted to show you guys an example, right? So for that, I'm creating in this dev sandbox, I'm creating a weather dev. So weather is my application name. So I have a dev database, I have test database, I have a production database. Okay, dev QA stage production, let's say. So I'm using a dev database. That's why I selected free tier. If it's production, then I would have selected definitely multi-AZ. Okay. So this free tier, it will make sure that only certain EC2 instance types are available for me, so that I will not be billed. It's free. 720 hours per month will be free for me. Okay, we'll take a look at that. I'll show you. So this is my DB instance identifier, my DB identifier, DB name. And credential settings admin, I'll pick up some, okay, this is my password. This is my admin password to the database, to this MySQL database. And DB instance size, see this one? I'm picking up db.t2 micro. T2 micro is underlying EC2 instance. All the other ones are disabled because I selected, here I selected free tier, and only db T2 micro is available. Okay. If I wanted to select any other databases, then I have to select dev/test or production. Storage, where do you want to store? It's a general purpose SSD. Of course, you can go with the provisioned IOPS. I highly recommend going for the provisioned IOPS for your production databases, because that's when you will get a lot of read writes IOPS. So allocated storage, 20 gig is fine for me. Storage auto scaling. If I start growing, if my database starts growing, do you want my database size to grow automatically? If I select enable storage auto scaling, then it will scale between 20 to 1000 GB. So it's almost until 1 terabyte, it will automatically scale it. That's fine, I will leave it. Availability and durability. See this one, multi-AZ deployment, it's disabled here. If I had selected production, then it would have been automatically turned on. It wouldn't even let me turn it off because of the nature of production, because you want your production database to be multi-AZ connectivity. But just by selecting this multi-AZ, you are getting essentially two databases in two different availability zones, meaning two different data centers continuously replicating from active to standby. So connectivity is virtual private cloud. It's in, please go into the default VPC. We didn't talk about VPC, don't worry about it. Additional connectivity configuration and what subnet, it's a default VPC subnet group. And take a look at this one here, guys. And don't worry about the subnet group, because you don't know what subnet is. You don't know what a virtual private cloud is. We'll talk about that this weekend. Publicly accessible. Do you want this database instance to be publicly accessible? If you select yes, then it will assign a public IP so that you will be able to connect to this MySQL database from your remote computer, from your machine. Otherwise, it will not be accessible outside of your VPC. So yes, I want to be able to connect to this from my computer, my remote machine. So I want my database to be publicly accessible. Is that the case with your production environment? Absolutely not. Your production database should be getting traffic only from your application servers, and your application server should be getting the traffic only from the web servers, and your web servers should be in WebDMZ.
Okay. Now the question is, see, suppose you give yes.
Hold your thought. Is it related?
Oh.
Or,
yeah, related, of course.
Yeah.
Yeah.
Go ahead. Sure.
Yeah. Suppose you give yes, and it's publicly accessible. Then with your database, I can access from my terminal also?
Excellent question. Yes, you can.
Okay. Okay.
It's again, what does it depend on? It's a great question. What does it depend on? You tell me. So far,
the availability of the
an
IP.
underlying EC2 instance, right?
Oh, your security group, I think.
Exactly. You nailed it. So it depends on security group. So publicly accessible. Did I answer your question, Sean?
Yeah, that's fine. Thanks.
And I will further answer your question. Publicly accessible, yes. So that means I'll have a public IP. So VPC security group. See here, it's already security group. Choose an existing or create new one. So maybe I'll create a new one. Let's see if I have an existing security group. I have a security group called database servers. Okay. I can take a look. I can show you how it looks. Let me show you. EC2 and the security groups. So please take a look at your, what's that called? Database servers. This is the database server security group. To look at the inbound traffic. See here, I already have a security group called database servers. So this is allowing inbound traffic 3306. That is MySQL's default port is 3306. So it is allowing 3306 from my source IP. But if I change it to everyone, then yes, you will be able to. Now you will be able to log in with this setting shown and everyone. Okay. So I'm going to pick an existing security group called database servers. Or you can first time, if you're coming here for the first time, create a new one. You call it database servers. I'll call this database servers 2. And the availability zone, no preference, database port is 3306. So yep, you are letting 3306 port to be open. Database authentication is password authentication. You're using your admin and your password that you gave above. If you want the IAM database authentication, you can choose that one, but I'm not. Additional configuration. As part of your DB instance creation, do you want to create a sample schema? Yes, I want to do that. And I'll call that sample schema as weather. And the DB parameter group, I don't need it. Backup, this is another one. Enable automatic backups. If you enable automatic backups, take a look at this one. Backup retention period. So how long do you want the automatic backups to be taken? 7 days, but you can pick up from 0 days to 35 days. So within this period, whatever this is called retention period, I'll pick up 7 days. So within this 7 days, I will be able to go back to any second. That's the beauty. And then I can provide a backup window. So if I say no preference, it will pick up. It will have its own backup window, but I can specify that I want this to be midnight of UTC or 2 o'clock of UTC for 30 minutes. You can specify when do you want the backups to be taken. And do you want enhanced monitoring? This is like your EC2 detail monitoring. If so, how frequently do you want it? The granularity? I don't need it. Okay. And
so what is this with 35 days? Is there any specific reason for like max 35 days or
that's
the backup retention period?
Yeah. So within that 35, most of the compliance reasons, most of the compliance are valid for 30 days, right? So that's why they must have picked 35. Because most of the companies, they want to keep it for 30 days and additional 5 days. So you're good from compliance reasons if you pick 35 days. So any day, any second within that 35 days, you'll be able to go back in time. But here in my case, within 7 days, I'll go back.
Okay. And this duration, one quick question. This duration, you say that within 30 minutes, the backup should be completed. That's what the intention is?
You are specifying start at 2 o'clock and then keep it for 30 minutes. There's no guarantee that it will exactly be done within 30 minutes. So during this backup window, okay, during this backup window, your database is not completely down. I want you to know that, but there could be some glitches here and there. So that your database is not completely down, but they could experience some slowness while the backup is taken. So that's why you pick a window that's where you will have very less traffic. Pick up your regular maintenance window.
Okay.
Yes.
See, once the backup has been taken at that scheduled hour, from that point onwards up to the next backup, it will keep on accruing the transaction logs.
You totally got it. You totally got it. That is how you don't have to worry. I mean, we don't have to worry about it, Shovan, but that is the strategy of AWS behind the scenes. You understand? So let's say at 2 o'clock, we took the backup, and then after that, it will continuously write the transaction logs. Let's say, give me the database give me a snapshot as of 7 a.m. Then what it does is it will take the hard backup as of 2 a.m. because it takes a complete snapshot, put it in S3. It takes that and apply all the transactions, all the commits from 2 a.m. to 7 a.m. and it will give you a snapshot as of 7 a.m.
Okay, then I can explain the thing that we were saying, that at the time of taking the backup, the production activity or writing database activities should be lesser. Actually, what happens is during the time of the backup, I'm guessing, it does not allow you to write at the database, but writes on transaction logs.
Not really. Transaction logs is the strategy that I mentioned is after it takes the backup, okay, from that point onwards, it will continuously, because it has taken a hard, so it's a combination of hard snapshot and continuous transaction logs is how it will be able to give you to the very
point in time.
Is my point.
Yes, but see, I'm guessing why. Because I'm familiar with RMAN of Oracle. Over there, what happens is exactly similar thing. But at the time of the backup, you can write to the database, but actually it does not write. But I've seen that at that time, if you try to write, it generates a lot more archive logs, transaction logs.
Okay.
So I had the guess that at the time of production backup, RMAN backup, it does not allow you to physically write, though it doesn't stop you, but it goes somewhere else. So I was thinking that probably the same architecture over here.
Here so what it, clearly documentation says that is it does, your database will not be down. It's available for you to read and write, but you will experience some delay.
Yeah.
Wonderful.
If you want to go back to the 30 days prior to the 30 days, do we need to depend on the EC2 AMI?
Can you say that again?
So this will give the 30-day retention period, right? So prior, if we want
retention period, okay.
35 days.
If you need,
prior, if
so
we
if
want,
you will not get it.
okay.
You must have taken a manual snapshot. If you did not take a manual snapshot, let's say if you need it for more than 35 days, you cannot rely on automated backups. You keep the automated backup as your strategy, okay, one strategy, but you also write your scheduled backups every 2 months or every quarterly based on your needs. You just take a manual snapshot and then put it out there in S3. Does it make sense?
Yeah. And if we enable the public IP, will it get charged, or is it part of the Elastic One public IP in the?
They don't charge you for public IP, no.
Okay, got it. Yeah. Thank you.
Yep. So come down. Maintenance, enable auto minor version upgrade. If there are any minor version upgrades to 8.17 to 8.18, then they will automatically take care of it for the database. If you want, you can enable it. Maintenance window, again, we talked about it. So any we talked about the database backup window, the maintenance window. During this period, if there are any OS level patching that need to be done to the underlying virtual machine, they will do it. You can pick your appropriate time based on your your scheduled maintenance. Yeah. So this is your estimated monthly cost. Because we selected free tier, it says there's nothing. Amazon RDS free tier is available to you for 12 months. Each calendar month, the free tier will allow you to use the Amazon RDS resources listed below for free. 750 hours of RDS in a single AZ. 20 gig general purpose SSD and 20 gig for automated backup storage. Make sense? Let's go ahead and create the database.
So do we use this deletion protection?
Can you say that again?
Do we need to use deletion protection as a like?
You can. Deletion protection, essentially, you will not be able to delete the database until you come there. This is like your EC2 instance. Underlying, because it depends on underlying EC2 instance, right? You have that EC2 instance termination protection, remember? That's what it does. So this is, your database will be created. So let's go ahead and create a new database, just for fun.
Another thing before we proceed to another thing, that is, see, RDS, we cannot SSH there, that's fine. But it's on some EC2 server. Now, the thing is, see, when it is growing and more disks are getting added to it, more volumes are getting added to it, are they block volumes? Are they block,
EBS volumes? Are the EBS volumes is what you're asking?
Yeah.
Yes.
And I'll be able to see that in volumes too? Externally?
No, because it's a managed service. You don't have to worry about it. And that is the main idea behind that, right? Behind the scenes, it uses the same EC2 and EBS volume technology, but we should be completely ignorant of the underlying stuff. It's a database provided to me as a service. That's all it is.
Okay, gotcha. Thanks.
Yep. So what I will do is, let's go ahead and create a new database. So we created a weather dev database, right? Let's go ahead and create a new production database. So it's a standard create again, MySQL, I'm creating it. And this time I'll be creating production database, okay? So I will call this guy as production weather prod. This is my prod database. And I've selected here as a production template. Please take a look at it and please take a look at the charges here, okay? Admin, some password. I'll pick up some password. DB instance size, standard class. Take a look at this one, guys. Earlier we saw T2 micro, right? Now this one, the defaulting to the standard class, memory optimized at burstable classes. M5X large is the default one. If you want memory optimized, then it will automatically, it's taking to R5X large, okay? I'll go with the standard classes. It's a 4 CPUs, 4 virtual CPUs, 16 gig RAM for your database, and its EBS volume is 3.5 gig Mbps. So let's go down. Storage is, did you see this one? It's not general purpose SSD. Of course, you can go back to general purpose SSD to save some money, but I want my production database to be provisioned IOPS, and I want my size to be 100 gigs to start with, and it will automatically burst up to allocated storage is 100, provisioned IOPS is, provisioned IOPS is 1000 IOPS, okay? MySQL, okay. Community supports 1000 to 80,000, sure, okay. So how many IOPS do you want it across is what it's asking. And storage auto scaling. I want this 100 gig to be automatically scaled up to 1000. Availability and durability, there you go. There is create a standby instance recommended for production usage. Looks like I can do without standby, but absolutely I want to create a standby. So please do that. Default VPC, additional connectivity information. Do you want this to be publicly accessible? Not really. And then choose existing, default VPC, port is 3306. This is all fine. Security groups. Let me select security group as a database servers. Security group. Okay, it's already selected. 3306 port, password based authentication. I wanted to show you this monthly cards. That's the reason I picked up this one. $1,524 per month. If I create this database, I'll get charged this much per month. Of course, it's they charge per hour billing. Make sense, guys? So this one, and imagine if you try to do that. This is the cost your company must be paying if they are planning on creating an RDS instance. MySQL. I did not even pick up Oracle. You play with it, Oracle Enterprise Edition, and you go down and take a look at the cost. Well, looks like it's the same price, Oracle also. But if you play with a couple of these IOPS and this is M5X large also. Okay, so this is a Oracle Enterprise Edition, Standard Edition, Standard Edition, Standard Edition 2. No, this is good. So I'm paying about $1,500 per month for my production database. Of course, it's two databases, active and standby.
Well, what's the database size? Maximum?
100 gig to start with.
100 gigs. And the RAM?
RAM 16 gig RAM.
Okay, thanks.
Okay, so I'm not going to create it, but I wanted to show you guys that. So go ahead and DB instances, click on weather dev. Let's see. Looks like my database is completely available. It's created, guys. So now let's go ahead and create, let's go ahead and take a look at this VPC security group, database server 2, inbound rules. Okay, inbound rules is my IP. So you will not be able to log into my database because it's open only to my IP. Okay, you can play with it to see if you allow it to everyone or to your IP, you'll be able to connect to it. So let's go to databases. Go look at here, guys, endpoint and port. This is the endpoint. Weather-dev, that's our database name, .com, blah, useast2.rds.amazonaws.com. This is my host name. This is my port. Okay, I already know my username and password. My port 3306 is open already to me, to my IP. So without delay, what I can do is, let's go ahead and install a SQL client. I've already installed a SQL client called Oracle SQL Developer. I created this Oracle SQL Developer. What I'll do is I'll just, let me go ahead and delete this guy. I already have it. So this is how it looks. So Oracle SQL Developer helps you connect to Oracle database, but you'll be able to connect to MySQL database also. How do you do that? You go to your tools, preferences, and go to your database and the third-party database JDBC drivers. You install your MySQL connector and add it, the jar file, add it here. Then you'll be able to connect to MySQL also. Click on your new connection, and then I'll call it weather dev. And then database type. Once you add your MySQL connector jar file, it will show you MySQL also. Now username is admin. My password is the password, and then host name is this is my endpoint, and port is 3306. Let's try test connectivity. Test is successful. Let's go ahead and connect. I should have saved it earlier. It's asking for my password again. Sure, I'm connected. Let's go ahead and see if we have our test schema. Weather schema is there. Very good. So I'm able to connect from my local machine to database that we just created in the cloud in AWS. It's that simple. Can you guys do that simply? It's that simple. Okay.
You haven't created any EC2 instance, right? So is it acting as a EC2, or is the RDS itself is on any EC2 instance or?
Absolutely. This guy, when you create the database, here, you go ahead and pick MySQL and production, sure, dev test, whatever, right? Go down, see here, DB instance size. See this one, db.m5x large. Is this not your EC2 instance?
Yeah, it's a EC2 instance. That's right.
And
Why do you say so? Show it again.
Yeah, DB instance size. See here. This is your DB instance class, meaning it's underlying EC2 instance class. Okay. If you select free tier, then you will see your favorite T2 micro. See here, and only T2 micro will be available, nothing else, because he's giving you this for free. 1 year. You will have your cloud database for 1 year, up to 20 gig. That's the beauty with your AWS free account. Does it make sense? And what is the underlying EC2 instance? Is T2 micro. Are you creating an underlying EC2 instance with DB? No, you are not. You just create your database, it automatically provision your EC2 instance, install your database that you picked with all the settings that it provided. Does that make sense? That is why it's called managed service. You do not have to worry about underlying EC2 instance.
Sure.
Somehow magically a database is provided to you and you have to use it.
This is a very strange thing that we did not see before. But you already gave it in the first slide you told us, and so that is fine. But the point is, see, what I saw this is not Aurora, but at one point I saw in one place it was written MySQL/Aurora. See, when you went to one place to look for the port, the port 3306, it says MySQL/Aurora. Why so?
Aurora is not a separate database. Aurora it's a MySQL or PostgreSQL compliant database.
Okay.
Aurora, what it did is, it's a MySQL. It took MySQL database, removed all the fat and made it AWS friendly, let's call it, in a loose term, right? And similarly, they took PostgreSQL. These are the two most popular community databases, right?
Yeah.
So they have taken Aurora, Amazon has taken these two databases and then made them cloud aware. Let's put it that way, or AWS aware. So my point is 3306 is the same port for your Aurora.
Okay.
That's all I'm saying.
Okay. But these are all in RDS.
What is that? These are all?
In RDS.
Yeah, everything is in RDS, yes.
RDS, okay.
Hey, Venkat, one quick question.
Sure.
So where do we see the read replicas here? Do we go with that one here anywhere?
We will see once your database is available, select and then go to actions and then create a read replica. So you'll be creating a brand new database using the existing database. Then you'll be creating a brand new read replica. Make sense?
Yes.
So now my point is, we have from my local machine, we connected to this weather database and we have this schema. I'm going to create a new table here called temp lookup. Okay. I'm going to show you how it works. So I have a simple application. It's a Java based Spring Boot based application. So the idea is that this is the use case, guys. My goal is to provide APIs. So you give me the zip code, I'll give you the appropriate temperature. And this API will read from my RDS database, MySQL database, okay? I'll have a table here. I'll create a new table called temperature lookup. It will have only two columns, zip code and temperature. That's all. I'll be creating it. So my application will expose two APIs, one for analyst. What analyst does is, analyst will upload the weather data.csv file into S3 bucket, and then it will call the REST API. it will say that, can you load the data into the database? And what my Java program is going to do it is, it will programmatically connect to my S3 bucket, get the file, weatherdata.csv file, and then parse it and load that data into database table. That is one use case. That's analyst responsibility. Now, everyone else, after the data is loaded, let's say we get the data every 2 hours or every, 2 times a day. So analyst will update the data into S3 and then call our API. Our API will go to S3, get the data and populate it into, delete the existing data from the database table, and it will insert again. And our regular API, our users will call the simple APIs. They will pass the zip code and they'll expect us to provide weather for that zip code. It's that simple use case. Let me go ahead and execute that. So let's go ahead and create this table called temp lookup. So create table temp lookup, and then I need 2. Take a look at this, take a look at this. Okay, it's
there.
Where is
The
my
zip code and
SQL?
temperature.
Okay, value. So temp lookup, I'll say zip code. Yeah, varchar2, varchar of 10. And then what's the other one called? Temperature itself. I'll use varchar also. Let me see if my Java program is using strings or, yeah, both of them are strings, so no worries. Okay, so I'm creating a new table. A new table got created.
But in the program you use zip, not zip code.
What's that?
See, you use zip. See in the put statement.
Oh, where is that?
Over here, come down a little bit. See over there, just after that, zip to temp map, put zip, comma temp. So I think you used zip throughout. I don't know.
Yeah, there's no.
That's fine. That's fine.
There is no column name here, right?
Okay.
There's no column name here. It doesn't matter. See, this one is just a variable name.
Yeah.
So this variable name has got nothing to do with this one. So weather.temp lookup. Very good. Unknown database. I think it's
So this is going to go and really write first.
Weather
Go and
dev,
write
yeah.
into the remote cloud database, MySQL.
Can you say that again?
So you are going to really go and write into the cloud database when you do a
That's
create
correct.
table?
That's correct. Yep. Now you will be able to actually.
But before that, you did not do any connection setting?
I did here, right? See here?
Yeah.
Plus connection, and then I gave MySQL, and I gave the host name here. Host name, I got it from my databases, my host name, my DNS name here, right?
Okay, what's the database name? Okay.
Click on this guy, and then you will see, see, it's an endpoint. This is the guy. Copy and put it here.
Oh, you did it before. Okay, I didn't see that.
Yeah, I did it.
Thanks.
So that's my, okay. So now what I'm planning on doing is, let's go to S3 for a second. My analyst, what analyst did it is, see this one, I have this next step training weather data bucket. Inside the bucket, I have this CSV file, weatherdata.csv. Already, if I don't have it, I can upload it. See, I have a CSV file. This is also there in my source code. Just upload it. Simple. Yeah. And then also I created a new user. I think I am using the existing user, HR user 1. I have a user. Maybe I should have called this weather user, weather analyst or something. But essentially, I have this access key ID and secret access key. Make sense? So let me take you to Postman here. See, this is my, go to S3 and my bucket name is next step training weather data. And then take this CSV file. Okay, I'll copy paste this guy. Do a HTTP get. You said method not allowed. Okay, I'm trying to do a poster. Let's do a get. There you go. This is the data of that CSV file. Make sense, guys? And I've used my access key and secret access key. You guys already did that. So now I'm going to programmatically read this file and then load all of this data into my database table. Okay. I wanted to show you my controller here, weather data feed controller. So some analyst will upload, my analyst is going to upload the data into S3 bucket and then call my REST endpoint. I can safely deploy this into a Tomcat in EC2 instance safely. Of course, I'm not doing it. I'll be running it from my local machine, but please do that. So my analyst will call this API /populate/weather data and take a look at this DAO.populate data. Take a look at this one, my AWS access key ID, and make sure these values are correct. Is this the best way to do it? No, you want to put them in your properties YAML file and get object request. This is your bucket name. This is your CSV file, S3 get object. We saw this, all of this. I'm reading, I'm using common CSV. I'm loading into the CSV record. And from there, I'm getting the zip and temp file, loading into a map. And I'm doing a delete everything from the existing table. See this one, delete from weather.temp lookup table. And then I'm updating row by row. Is this the best way to do it? Probably not. You may want to use the Spring JDBC templates batch update or something like that. But the goal here is not the Java, not Spring, any of that, right? So that's my controller. This is my analyst calls this controller. Now there is another controller.
So you have a Tomcat. So you have a Tomcat running on your local, right?
Yes, it comes with once you have your STS, it comes with it.
Yeah. Okay. No, but you have to start it up. As far as I remember, I learned it from you only.
Absolutely. We'll do that. Okay. So my analyst will call this REST API to load the data into the database table. And this guy, my regular people, they'll call this API /weather/ they'll pass me the zip code, and I will call the service.getWeatherByZip. And my service class has a simple select temp. Okay, did we call the column name temp? Yes. Where temp.lookup, where zip equal to, you are right. Thank you for that. And let me do a drop table, or I can do an alter, probably. Alter table. Can I do a rename? Zip, right? Alter table, rename column, zip code. Is it 2? I'm not sure. Not bad. Okay, zip and temp. Very good. So query object, and then essentially I'm using a simple Spring JDBC template. Well, you can use fancy JPA with some provider out there, but you got the point. Yeah. Let's go ahead and run it. Run as Spring Boot app.
Ah, okay.
I'm now running Tomcat.
Yeah, that's fine.
And my weather data feed controller, if you look at it, it's a put mapping, meaning it's a HTTP put. So let's go ahead and call this guy. I'll go to my Postman, and then I'll say here, HTTP ://localhost 8080/ populate/weather data. Let's call this API and do a HTTP put. Okay. And this guy, take a look at this one here. It's programmatically going to S3 in this bucket, in this particular object. It is getting it using CSV, common CSV library, Java library. It's loading all of it and then calling Cloud JDBC. Oh, okay, wait. I have to give the appropriate JDBC details, right? Those are provided here. Let me stop this guy. In application.properties, I have to give this appropriate my database details. Where is my database host name? RDS. This is my host name. Endpoint is the host name. JDBC : MySQL : my host name : port number / your schema name. This is my driver class name, com MySQL JDBC driver. Username is admin, password is admin1234. I think that makes sense. Yep. All set. Let's go ahead and do it. Run as Spring Boot app. I'll clear the logs. Now I'll go ahead and do the populate weather data API. I'll call it. I'll observe the logs. I'm using a Hikari database pool. Looks like it's loaded. I mean, I don't have any errors here. Let's see if it's really got loaded. There you go. So our cloud database that we just got created, the table has been fully populated with the data that we read from a CSV file from S3, parsed it and loaded into the RDS, so that our regular people, they will not worry about connecting to the S3. Only our analyst will call the REST endpoint, this REST endpoint, okay, and say, load the data. They load a couple of times. They will load it to S3, and then they will call this REST endpoint. Later on, we will automate this when we learn the concept of lambdas. So with lambdas, what we will do is, as soon as the file is uploaded, an event gets triggered and some piece of code will get, will take that event, automatically read the data and load it into the database. That's all. Piece of cake, right? So now what we will do is we will go to the actual weather controller. We will call this guy. Let's do a HTTP get. HTTP : localhost 8080 /weather /zip code. Okay, let's use one of the zip codes that's out there in the database. 12356. 12356. 18 degrees in the database. 18C, yes. 10408. 63F. There you go. Now our code has populated this, right? You can insert a new record here. Insert into, I think you get the point. I don't need to do this, but what's your zip code, Showan?
43230.
43230. About, let's say 67F right now. That's it. So let's query through our API. There you go. That's it, guys. So that's about it.
Venkat, are these Java codes and everything available in your GitHub?
Absolutely. It's
the
available.
One that you give us?
Yes.
So which repo is that?
This is called Weather App. I'm
Weather
just
repo?
looking it right now. Any changes?
Okay. Weather data setup?
Weather data, everything is, it's called Weather App. It's out there. So.
Oh, okay. Okay. I think weather data setup. Weather. I see one weather, but I don't see any weather app.
This must be, I'll let you know probably.
Okay.
I'll have to revert it and I'll take care of this one.
Okay.
Any questions on that?
Not on these.
Excellent. So we'll talk about DynamoDB and consistency models within DynamoDB and Redshift and Elasticache. These are also important for the exam. Okay. I'll make a separate video on that. That's all, guys.